All right, so this is the example for the class pick slides 1, 2, and 3. So Quentin just read that his computer, which costs $2,000 when it's brand new, loses 20% of its value every year. So the first thing we need to do is write the function for the computer's value after T years. So the first thing we need to do is find the initial value and the rate. So we're going to say they tell us it's E of T, and then I know because it says 20%, I know it's exponential, so I need the initial value, the rate, and the exponent. And I already know the exponent is going to be T because that's what is inside the parentheses over there. Once we see this, we know that that's the exponent we're going to use. So then the initial value is 2,000. We use a different color, 2,000. So this is going to be 2,000. And then the rate is that it loses 20%. So don't just put 20% in here. We needed it to be a what's missing. Remember our candy bar, if we lost 20% of our candy bar, if we gave it away, or if the computer loses 20%, that means that 80% is left over. So 80% is the rate. And we remember we can't put a percent in, so I need to change it to a decimal, which would be 0.8. So that's the equation, and now I need to use that equation to give an estimate. Or if the estimate is accurate, how much will the computer be worth in 18 years? Since it says every year, that means I have 18 years for that. So I'm going to put 18 in for my T. So when I type it into my calculator, I'm going to get, 2,000 parentheses 0.8, close the parentheses, to the 18th year. And I get this. Now remember, we're talking about money. So when I go to write my answers, I'm going to make sure that I include the dollar sign at the front, because that's where it should go, even though it sounds like it should go at the end. And it's $36 and 0.0. Now remember, we normally round to the third decimal place, but because this is money, we're not going to. We're going to actually look at the 8. We're going to look at the 8 on the calculator. All right, let me pull it over here. We're gonna look at the 8 on the calculator, and that's gonna tell us around the 2 up to a 3. So instead of writing out to the third decimal place, because we can't have fractions of pennies, so his computer is gonna cost $36 in about 18 years, which it sounds about right. Now, if they switch this problem, and instead of saying that it's for every year, and let's say they decide to make Quentin's computer lose 20%, let's say they say every 7 years, and they want us to find it after T years, then we're gonna, the only thing that's gonna change is we're gonna take the same answers we just got over here for this equation, and the only thing is that now it's out of every 7 years, so that's gonna be T over 7. Which means when I plug in for 18 years, the 18 is still gonna go in for T, but it's gonna be the numerator for this. So if it's 18 years over here, so in my calculator, I'm still starting off to 2,000. It's still going to be 0.8. And now this time when I do my exponent, I'm going to remember to put it in parentheses because this is a fraction, 18 over 7. And so it's actually going to be a whole lot more, worth a whole lot more money. It's going to be worth $1,126. And still I'm going to the third decimal place. So when I do this, I'm going, or to the second decimal place. And when I use the third decimal, I'm going to use the 3 to round the 6, and that 3's tell me that the 6 stays. So my final amount with my dollar sign in the front is 1,126 and 76 cents. If it asks you for the factor, remember, whenever it says factor, we just use the parentheses and the exponent. That's all we're needing to do is the parentheses and exponent. So if we did the one for the 7 years, the rate would still be 0.8. That wouldn't change. And then the factor for 1 year, if I was doing 7, would be 1 over 7. And this would be an exponent. It doesn't really look like an exponent here. Let me make it look like an exponent. 1 over 7, because we're looking for 1 year out of the 7 that it takes to lose the 20%. And if we write it like this, then remember we can write it like a radical with our rate underneath, so 0.8. And you could just write 0.8. I just always write 0 so that way you know that this dot wasn't a mistake. And then the denominator comes out into the front. And if we needed to put the 1 somewhere, it would go back here. All right, so that's the questions for slides 1, 2, and 3.